All right, so real quick, today we're going to focus on tangents, which we've already done, but I wanted to do a little bit of a review since we're jumping back into the circle chapter from our polynomial little mini chapter. So remember a tangent. A tangent line intersects a circle at exactly one point. This is called the point of tangency. A line is tangent to a circle if and only if it is perpendicular. So we have this going on here, perpendicular to a radius drawn to the point of tangency. So you have a couple different problems with this. First, we're going to determine, is AB tangent to circle P? Well, what this is asking, if this truly is tangent, then this would be a 90-degree angle. Okay, the tangent line and the radius form 90 degrees. So they gave us all three pieces of this right triangle, well, in quotations, right triangle, because we're trying to check to see if it is. So when we do this, we're going to check and ask, is 17 squared, the hypotenuse, what's across from the hypothetical right angle, is that equal to 8 squared plus 15 squared? And of course, I don't have my calculator handy. Let me get this. Sorry, guys. So 17 squared is 289. I'm trying to figure out, is that the same as 8 squared plus 15 squared? Well, that's 289. Since these are equal, yes, this is 90 degrees, so therefore AB is a tangent line. Now here, this would be a 90-degree angle if AB was tangent. So I'm asking, is the hypotenuse, okay, this hypotenuse here from B to P. Now careful, they didn't give us the whole piece. They gave us this 5, and then we have to figure out what this is. Well, this is the radius of the circle. This is also a radius of the circle in here, and wherever else I decide to draw it. So if I fill that in with an 11, I now know that BP is 16. So I'm trying to figure out, is 16 squared, is that equal to 14 squared plus 11 squared? So 16 squared gives me 256. Is that equal to 14 squared plus 11 squared? 317. Those numbers are not equal, so no, that is not a tangent line. It did not hit it exactly 90 degrees. So now this is figuring, this time they said if JK is tangent, so I don't need to ask, is that 90? I know it's 90. Find x. So now we're just doing the Pythagorean theorem. In this case, we get x squared is equal to 7 squared plus 19 squared. X squared is equal to, this all becomes 410. Take the square root, x equals the square root of 410. 20.2. All right, now let me think. So let's take a look at a problem like this. They want us to find x, which goes from here to here. All right, well, I know that from here to here is 10. So there's a couple different pieces to this. What I can do is I can solve for the entire hypotenuse. So I'm going to go with y. Okay, I'm going to call this entire hypotenuse KLY. Y squared is equal to 24 squared plus 10 squared. 24 squared plus 10 squared gives me 676. Y squared, I take the square root. The square root of 676 is 26. So y is 26. That entire hypotenuse is 26, but I want x. Well, I know that x is going to be equal to 26 minus 10, which is 16. All right, so you're going to have to work that a little bit. This down here, let's try number 8. I know the hypotenuse of this is 25. One of the legs is 7, and from here to here is x. Okay, now that means from here to here is x. So this entire side has a length of 2x. All right. So there's a couple ways we can do this. What we can do is call this y. All right, so I know that 25 squared is equal to 7 squared plus y squared. So 25 squared gives me 625. That is equal to 49 plus y squared. Subtract the 49. 625 minus 49. 576 is equal to y squared. We take the square root. The square root of 576. Y is equal to 24. So if this whole thing is 24, but I have two of them, I cut it in half and I can see that x is equal to 12. Okay, there's other ways to do this using quadratics, but that's up to you. All right, the last piece were the other tangent line properties. If two segments from the same external point are tangent, so if I know that AB is tangent to the circle and CB is tangent to the circle and they share this point B, then I know that this piece is congruent to this piece. So also if a polygon is circumscribed, okay, so if we have a polygon on the outside of a circle, then all of the sides are tangent. So that means this is tangent right here with the radius. This is tangent. So that means this is congruent to this, but also this is congruent to this, and these pieces are congruent here because they're sharing these points. So you'll get some easy problems. I know that if this is tangent and this is tangent, says all segments that appear to be tangent are, then this is equal to this. So you set up a problem, 5x plus 23 equals 8x minus 19, solve for x. All right, now we also have these problems down here where they want us to find the perimeter. So we want to find this plus this plus this. Well, what we have is this is circumscribing this figure. So therefore, HE is 16, so this is 16 here. IF is 9.5, so this piece is 9.5. DG is 11, so DH is 11. Then we just add them up. We have a 27. Across here, we have 25.5. And here we have 20.5. We add them all up, and we get a final answer of 73 is the perimeter. All right, so that is all that you need there. You will have your assignment on that. I will see you tomorrow for inscribed angles.